Hi everybody again, Mr. Yoder back with another video. It is Wednesday, the 22nd of April. Hopefully you guys are doing well. We are going to go ahead and continue through this module, this last module of the year. Today we're continuing to talk about probability. Our objective for today is to understand the multiplication counting principle, also known as the fundamental counting principle. Okay, the multiplication counting principle. Let's look first at this explore activity. So counting possible outcomes. Part A, we're going to start off kind of simple to illustrate our point here. So part A says to find the number of possible outcomes from one coin flip. So how many outcomes are possible? If I flip a coin, how many possible outcomes are there? Well, you can get heads or you can get tails. That's two possible outcomes, right? Pretty simple. Part B, complete the list of all the possible outcomes from two coin flips. Okay, so let's say we flip two coins now, or we flip it twice, I should say. We could get two heads in a row. We could get a heads and then a tails. We could get a tails first and then a heads. Or we could get two tails in a row, right? So there's four possible outcomes if we flip two coins, right? Now in part C it says in the space below, I'm actually going to do it over here, okay, just because it's more room. In the space below, use a table, tree diagram, or an organized list to find the number of possible outcomes from three coin flips. So we want to flip the coin three times now, and we want to know how many possible outcomes there are. What I'm going to do is I'm going to show you a tree diagram that we can use to illustrate this. Okay, so here is our tree diagram. So here's our first toss, here's our second toss, and here's our third toss. First toss we get heads or tails. Now branching off from each of these, we could also get heads or tails on our second toss. Okay, and then our third toss, again, the number of outcomes doesn't change on the third toss, it's still heads or tails. So we're going to go heads to tails, heads or tails, heads or tails, heads or tails. This is a list, this is our sample space then of all of our possible outcomes, right? We could get three heads in a row. We could get two heads and then a tails. We could get heads, tails, then heads. Heads, tails, tails. Tails, heads, heads. Tails, heads, heads. Tails, I just said tails, heads, heads. Tails, heads, tails. Tails, tails, heads. And tails, tails, tails. Okay, so now let's count how many there are. There's 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes from flipping three coins. Okay? Now, using the multiplication counting principle, with a small number of trials, drawing a tree diagram or making a list of possible outcomes works well. So like if you only have, two or three events, it's pretty easy to draw a short little tree diagram to illustrate all your sample space and how many outcomes there are, right? But if you get more and more, or if the number of outcomes gets higher and higher, like let's say there's 50 outcomes in one of the events, you don't want to draw out 50 outcomes in a tree diagram because that would literally take you forever. There's a much easier way that you can do it, okay? You can use what's called the multiplication counting principle to find the number of possible outcomes. Now, what the multiplication counting principle is if an event can occur in m ways and another event can occur in n ways, then the two events can occur when you combine them in m times n ways. Now that might seem confusing. Let me say this. Okay, so let's say we've got three events happening. Let's just go with the coin flip idea, right? What this is saying is that the first coin flip can happen has two different outcomes, right? Heads or tails. The second coin flip also has two outcomes. The third coin flip also has two outcomes. So what it is since we have three coin flips, each of them has two outcomes. How you find the total number of possible outcomes is you take 2 times 2 I am not writing correctly today. Oh, 2 times 2, not 2 times x. 2 times 2 times 2. There's 3 events. 1, 2, 3 events. So you take 2 times 2 times 2, which is equal to 8 possible outcomes. And that's actually what we got when we did our tree diagram, right? We got 8 possible outcomes. Okay? Because here you've got your first toss, there's 2 outcomes. Our second toss, you take each of these and you add 2 more for each one. And then each of these you add 2 more for each one. So this is 2 times 2 times 2, which gives you 8 possible outcomes. Okay? All right, let's look at a couple of examples of how this works. It says find the number of possible outcomes for each compound event. Remember, a compound event is when you have more than one simple event. So here there's 52 cards in a standard deck. Suppose you draw a card at random, replace it in the deck. Okay, this is important. You take the card, you put it back in, and then you draw a second card at random. So there's 2 events here. We're drawing it once, putting it back, and then drawing it a second time. That's 2 events. So how many possible outcomes are there from drawing a card out of a deck once? How many outcomes are there? There's 52 cards, right? So there's 52 possible outcomes. Okay. Now our second event, how many possible outcomes are there in the second draw? Well, since we replaced the first card back into the deck, there's still 52 cards in the deck. So our second event also has 52 possible outcomes. So to get the total number of outcomes, we want to take 52 times 52. So we're going to come over here to Desmos. Let me open Desmos up. So we're going to do 52 times 52, and we get 2,004 possible outcomes. Sorry, 2,704 possible outcomes. Can you imagine drawing out a tree diagram to represent that? You'd have to draw 52 outcomes in the first branch, and then from each of those you branch off 54 or 52 times. That would take you literally forever. Okay? And by literally, I don't mean literally, I mean figuratively forever, right? Eventually you'd get done with it. All right, part B, drawing a card at random and then not replacing it, and then drawing a second card at random. So here, our first draw, how many cards are there? There's 52 in the deck, right? So 52, but now we don't put it back. How many cards are left? Now there's only 51 cards, right? So we want 52 times 51 now. So we're going to take 52 times 51, and that gets us 2,652. 2,652 possible outcomes. So there's a few less number of outcomes from part A. So now there's slightly fewer total possible outcomes. All right, part C. How many outcomes are there from rolling a number cube 3 times? So we've got a dice, we're rolling it 3 times. We want to know all the possible combinations we could have. Okay, what are the possible, how many outcomes are there for rolling it once? Well, there's 6 outcomes on a dice, so that's 6. So if we do this 3 times, it's going to be 6 times 6 times 6, right? So we're going to come over here, 6 times 6 times 6, that's 216 possible outcomes. Okay, and then last, part D, creating a computer password that consists of 3 letters followed by 3 digits. Now this one's a little bit more complicated, right? We have a 6-digit password here. The first 3 letters, the first 3 digits are letters. The last 3 digits are going to be actually numbers, right? Now, for our first 3 letters, and we want to know how many possible outcomes of passwords that we could have, right? So first, we're going to have something times something times something times our 3 digits. So this digit, and this digit, right? So these are our letters. The first 3 are letters. So how many letters are there? How many possible letters are there? Well, if you count A through Z, there are 26 letters in the alphabet. So it's 26. Okay. Now we can have the same letter more than once. So for our first three, it's going to be 26 times 26 times 26. Those are our 3 letters. Then it's followed by our 3 digits. Now, there are 10 digits, right? You can have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so there's 10 digits right there. 0 through 9 is 10. So we're going to do 10. And again, these digits could repeat. So 10 times 10. 10 times 10 times 10. Okay, now this is kind of a long one. So we're going to come over here to our Desmo. So we're going to do 26 times 26 times 26. Then times 10 times 10 times 10. And it's not typing. Why is it not typing? Okay, let's try this again. 26 times 26 times 26 times 10 times 10 times 10. And we get this big old long number right here. So this is 17,576,000 possible outcomes. Okay, that's a lot. Okay, I don't even want to get started on drawing a tree diagram for that, because that would take a very long time. Okay, here's what I want you to do. I want you to go ahead and see if you can figure this one out on your own. When Sheena gets dressed, she chooses from 4 shirts, 2 pairs of shoes, 3 pairs of pants, 2 hats, 6 pairs of socks, and 3 accessories. Suppose that she randomly selects 1 item from each category. Find the number of total possible outfits possible. I want you to pause this video, see if you can figure this out on your own. See if you can figure out how many possible outfits she could have. Alright, so hopefully you paused it and figured it out on your own. If not, please do so now. Okay, we're going to figure out how many possible outfits that she could have. Well, she's got 4 shirts. Each of these articles of clothing is like picking is like one event, right? So 4 shirts times 2 possible pairs of shoes times 3 pairs of pants times 2 hats times 6 pairs of socks times 3 accessories. And now we're just going to multiply all these together to get the total number of possible outfits that she could have. So we're going to come over here. We're going to do 4 times 2 times 3 times 2 times 6 times 3. And we get 864 possible outfits. Okay. 800, what did I say? 864 outfits. Okay, so hopefully you were able to get that right. If you didn't, hopefully you can at least see what mistake you made getting your answer. Okay. Next example, at an ice cream shop, a customer chooses 1 each from 10 flavors of ice cream, 5 toppings, 2 types of cones, 3 sizes of cones. Okay. So there's 4 events here. We want to choose the flavor, we want to choose the toppings, 1 topping, we want to choose a type of cone, and we want to choose a size of cone. So there are 10 flavors times 5 possible toppings times 2 types of cones, and then times 3 sizes of cones. So we're assuming that you can only pick 1 of each, by the way. Okay, so there's this many possible outcomes. So we got to take 10 times 5 times 2 times 3. So 10 times 5 times 2 times 3, and we get 300 possible outcomes of ice cream. Okay. All right, I think we kind of get the idea. So we're going to go ahead and skip the rest of this. And your assignments, you have a quizzes. So you're going to go ahead and go to quizzes.com. This assignment is on there. Make sure you log in with Google. A lot of people are have had some issues. Not a lot of people. A few people have had issues finding it. You say, oh, how do I get to the assignment? Yeah, make sure you log in with Google. Okay. At the start of the year, you signed up with my class using your Google login. That's how you'll be able to find it. Just make sure you go there, sign in with Google, and you'll be able to see it on there. Also, a reminder, Since today is Wednesday, it is your class's time for a live Q&A session. So the Canvas live Q&A with me is today from 1 to 2 p.m. So if you guys want to come, if you have any questions about your lesson, this lesson, your homework, maybe you have questions about your grade, a missing assignment that you have, or if you just want to come and say hi and hang out for a little bit, feel free to come. It starts at 1 o'clock and it lasts until 2 p.m. So that is an option for you. If you have any questions or you need any help with anything, feel free to come on by. Okay, I hope you guys have a great day, and I will see you guys on Friday.